Hey everyone, for joining and just wait for a few seconds till some more people can join in and then we can kick start our webinar. So thanks for joining from wherever you are. Your time is super valuable to us. So welcome to our webinar, Elevate Your AI Apps with Database Branching. My name is Yukti and I will be your moderator today. One of my main jobs here at SingleStore is to organize, plan, and conduct these weekly AI webinars. We organize 2 webinars per week. Sorry for the previous webinar that got cancelled. So we are planning to reschedule that one. So if you were waiting for that one, coming from that, and if you're a regular, stay tuned, we'll let you know. So also post about our upcoming webinars here and now. So if any of these topics are interesting to you, feel free to connect with me to stay in loop. And I'll also like to hear your feedback or ideas on topics that you would like to see in future sessions. So feel free to connect with me and drop a message to me or anyone from the team on LinkedIn. So speaking of future sessions, as you can see on your screen, we've got multiple informative new webinar sessions that are coming up. Next week on August 14th, we have Getting Started on SingleStore, a pretty basic webinar for anyone who's new with SingleStore as a product. So we'll have Akmal, who's a very regular speaker at our webinars, join in and speak. On August 16th, we'll have how to make full stack MongoDB and JSON apps 100x faster. And on August 19th, we have LLMs in financial services, personalized portfolio recommendation engines. So if any of these topics are interesting to you, RSVP right now, and I hope to see you all there. Coming back to today's topic, you're welcome to participate in the discussion throughout the session using the Zoom Q&A button, which is present at the bottom of your console. We have an internal mission statement to try to answer 100% of the audience questions, even if that means following up with folks afterwards via email. This has gotten a little difficult over time because we have a lot of questions sometimes, but we're absolutely up to the challenge. Just make sure to ask away and make sure that you have logged into Zoom with your actual name and email address, because we generally do not take any anonymous questions. As you can see on your screen, we would like you all to have a dynamic experience during this webinar. So feel free to try out SingleStore notebooks. Anyone who tries it today will be entered for a chance to win either branded new AirPods Pro or Meta's new Ray-Ban LLM smart glasses. It's absolutely your choice. It's simply click this link that's present on your screen, or you can scan the QR code and just log in. You may know that SingleStore has had a free trial offer for many years, but in the past few weeks, we've also announced a new free share tier, which we might talk about a bit later today. So moving on, yeah, it's just a small FYI. We will be announcing 2 winners for this session. One winner will be anyone who has attended, and the next winner will be based on the people that have actually tried during the webinar. So stay tuned for that one. And okay, moving forward, allow me to announce our amazing speakers today. We have amazing SingleStore experts joining us today. We have Mohan, who is a staff product manager here at SingleStore, and we also have Rohit, who is a cloud solutions engineer. So very happy to have you both here, and welcome to the audience. And Mohan or Rohit, like whoever would like to go first, the
Sure.
floor is now yours.
I'll jump right into it. Thanks, Yukti. Appreciate this. So today's agenda is that we will start with discussing just a little bit about who we are. Then I'll spend just a few slides about what SingleStore provides as a value to our customers. Then I'll jump right into the webinar, today's webinar, the key topics, which is to talk about database branching and how it improves developers' productivity. Rohit, my partner, will talk more in detail about our Gen AI capabilities. Then we will demo these 2 features by showing a practical use case. And finally, we'll close it up with Q&A. So who are we? Right. As you can see, we are a very matured enterprise database company. We were first founded in 2011, so that's almost 14 years ago. And we initially were called MemSQL. And the reason is that we started off by supporting in-memory row store table types. And because of that, speed has always been in our DNA, and will continue to improve our query performance over time. If we fast forward to 2020, now we have rebranded ourselves as SingleStore. And primarily the reason we rebranded ourselves to SingleStore is that after listening to customer feedback, Along with row store table types, now we also support column store table types. So customers can run both their transactional queries, OLTP, as well as their analytical queries, so OLAP, and bring these two use cases under a single database, which we are calling it SingleStore. As you can see, around the same time, around the 2020, our company started hitting a really good growth spur, and now we are at 100 million ARR with, and this is the best part, we have over 350 plus really happy customers. All right, so let's talk a little bit about our product and what differentiates us as SingleStore. I'm going to break it up into 4 parts. One is ingest. This is the first thing. And this is also one of our key differentiators, because as customers are ingesting more and more data, we have something called pipelines that can scale up or scale down to support a really fast ingest. So we can now support over hundreds of millions of rows per second. And along with that, we also support various common technologies like Kafka, Hadoop, Spark, and also more recently, natively, we're supporting Iceberg tables, which is a big add-on. The second aspect is that we run anywhere. This flexibility is something that our customers really like. So we support both as a managed service, which we are calling Helios Cloud, on all 3 major cloud providers. So that's AWS, GCP, and Microsoft Azure. But also as a self-managed, we support all on all these cloud providers, or on your own data centers, or as on-prem. So that's a huge flexibility for our customers. We are also multi-model. What that means is that we are able to support various different types of data types. An example here, a few examples here would be that, as you can see, relational data type is a very standard thing. And we're really good at it because all our transactions are not only ACID compliant, but we also have 2PC consistency across our distributed tables. A lot of our customers are also using us for full text search. Along with full text search, we have a lot of JSON and BSON data under management. Rohit will talk a little bit more about vectors in the next few slides, but we now also support a native vector data type. Along with that, to improve our query performance, we are also supporting an ANN, or approximate nearest neighbor index. We also have few customers around geospatial and time series that are using SingleStore for those use cases as well. And finally, applications. Right, our table stakes, or a lot of our customers use us for real-time data analysis or building dashboards over terabyte scale data to get real-time analysis. But now lately, customers have also been building AI applications on top of SingleStore, primarily because now we support the natively a new vector data type. All right, so that's a little bit a brief overview about SingleStore. But let me just talk also about how SingleStore works under the hood. This will be a good foundation for upcoming slides. And we'll start with ingest, right? So you ingest data. By default, we store your data in the column as on disk as column store tables. But if you really want fast performance, we also support in-memory row store tables. So you ingest the data gets stored either in row store or column store tables, but asynchronously, we are storing all of that in object storage also, which we are calling unlimited storage. And the reason is that the storage scales up to based on your storage needs. And therefore, we are also supporting up to petabyte scale databases at SingleStore. And as you know, object storage is extremely durable, 11.9 durable. SingleStore is also a distributed database. And what that means is we have an aggregator and leaf architecture. all your data is stored on leaf nodes and broken down in partitions for faster data retrieval. And because of that, scaling up and scaling down is super easy, right? So if you have higher demand, you just add on more nodes and you scale up. And if you want, and when the demand drops out, you can scale down. All the users and queries, they interact at the aggregator level, and the aggregator's job is to be able to go down to the leaf nodes and fetch the data needed for the queries and respond back to the users. Therefore, we are also highly available. What that means is all your data is stored in at least 2 different locations, so that if a node goes down, the aggregator will automatically switch over to the secondary partition and completes the query. So your application will never even know that a node went down, and therefore there's absolutely no downtime. So now that we have had a good overview about SingleStore, let's jump right into today's goal. Our goal for today is to show how database branching can improve your productivity. And we're going to demo a RAG or retrieval augmented generation app that we built on top of SingleStore database to be able to test how you can easily do prototyping using database branching. So let's just spend just one slide talking about what is database branching, right? So imagine this as a developer, if you want to prototype a new app or test a large query or a business rules, right? Like you want to update and delete a bunch of rows. You obviously don't want to do that directly on a production database, right? You want to first create a staging environment or dev database and test on top of it. But today, to do it, you either have to create a new database and ingest a bunch of mock data into it, or restore from a production database to have more realistic data that you can test on. Both of these processes can take a long time, and depending on how big your production database is, this can also get expensive, right? This is where database branching drastically improves the productivity, because with just a simple command, you could quickly and cost effectively branch or essentially create a new dev database. And here, when you're branching, you're just cloning the data, you're not duplicating it. So you're not also incurring any extra storage, right? And this branch or a new database that you created acts as an independent database. That means you can play around with it by updating, deleting, or making any changes. And it never impacts the production database, which is the most critical aspect of being a staging environment. Another uniqueness about SingleStore branches is that you could create a branch at the current time or also in the past at a previous point in time, and that opens up with really unique use cases. For example, think about point in time recovery, right? So you have a reporting database, you ran a query, and by mistake you updated a bunch of rows, right? So now all you have to do is instantaneously just create a branch before you ran that query, so that branch will have all the data before any updates have happened. And then you can use that to restore your tables or just switch over and make the branch database your primary database. So it really opens up for many different use cases. So how do you do branching, right? As I promised, it's really easy. All you do is a simple SQL command, attach database, show your parent database name as, and show what your new database name should be, and that's it. Within a minute also, a new database is created with all the data that your parent database has. And if you want to try, branching is live right now. Feel free to go create a trial, and it's free. Just try it out. So now I'm going to hand it over to Rohit, who can talk more in detail about our Gen AI capabilities.
Awesome. Thank you so much, Mohan. That was a great overview of SingleStore and database branching. Next slide, please. So as we kind of move into the world of technology powered by AI, or in other words, these AI-enriched applications, essentially what we want to do is to be able to give our LLMs the capability to know, understand, and work with our data. So there are 3 ways to do this. First way is to retrain an LLM from scratch. The second way, which has the same problems as the first way, would be to fine-tune an LLM. Both of these are problematic in that you will need a bunch of investment in time and resources in order to be able to actually build out an LLM or architecture that takes advantage of retraining or fine-tuning. The third way, which has gotten very popular over the last couple of years, is retrieval augmented generation. So when it comes to retrieval augmented generation, essentially what you're doing is you are passing in all of the relevant information for your application to the LLM as context. Essentially, this amounts to going to ChatGPT and pasting all of the information you want into the chat box at the bottom. That way, the LLM will know the information it's present as part of the context. So let's go ahead and see how a typical enterprise will try and implement this on top of their currently existing technology stack. So, of course, to start off with, you will have your end users interacting with an OLTP database through the application layer. And your enterprise users will want to do analytics on top of that. So typically what they'll do is they'll ETL the data out of the OLTP database, enrich it with some internal communications, internal documentation, and so on. And they'll be able to perform analytics on top of that. But now, for example, if your application becomes slow, maybe you have large volumes of data that you want to store elsewhere. Maybe you have data coming in document format that you need to search through. Maybe you have some sort of streaming data. Mohan, can you build it out a little bit? Awesome. So all of this kind of adds to your technology stack because, of course, at the end of the day, you need a performant architecture. As you can see, you have a lot of different pieces here. You have caching, you have document, you have search, and you have a bunch of ETL tools and ETL jobs that are moving data from here to there and all over the place. What this does is it adds latency, it adds inaccuracy, and adds cost. At the end of the day, you're only going to be as fast as the slowest component of your architecture. And now, in order to build a RAG application, you want to add another database, a vector database, to the stack. So let's go ahead and zoom in on that RAG application that your enterprise wants to build. This is a holistic overview. And now over here, you can see we have the RAG application. So typically, your end user is going to be asking questions to your GenAI application in some sort of natural language. Now, the typical RAG flow is you're going to go to the vector database, you're going to do vector search on the embedding vector for the question, and retrieve relevant vectors from the vector database. Then you need to go to your OLTP, your OLAP, and your other systems to bring in the relevant context. Remember, you are not going to paste the results of the vector search into the context for the LLM. You're going to be pasting actual enterprise information. That's going to be your context. So you need to retrieve that from the OLTP system, from the OLAP system, and so on. Essentially, what you're going to have to do is, once you have all that data, is you're going to have to stitch it together into a prompt and then send it to the LLM in order to retrieve a natural language response. The problem with this is that you have many disparate systems interacting with each other. And I really want to reiterate this one point. You are only going to be as fast as the slowest component in your architecture. So if your OLAP system is slow, maybe you're using a NoSQL database for some sort of analytics, you're going to get your response times, your latency is essentially going to be dependent on that itself. So that's essentially, what this technology stack looks like when you apply it to retrieval augmented generation. Now, wouldn't it be nice if you could build this RAG application on top of a database which could support a rich set of data types like you see on the screen here? And like Mohan alluded to earlier, these are the data types that SingleStore can support. Structured data types, semi-structured data types, and I want you guys to notice the JSON and BSON support here. The unstructured data types such as text, the geospatial or pSQL data types. But importantly for your RAG application, at its core is vector search, and SingleStore supports the vector data type as well. Now, of course, having the data types themselves is not enough. You need to be able to search and query this data. And of course, being able to do that in your singular database for the RAG application will essentially allow you to build a very simplified architecture. right? So again, going back to SingleStore, we have powerful search and query capabilities. The ones I want to focus on are the nearest neighbor search. This is an application of vector search. We have approximate nearest neighbor search. This is what allows you to kind of search over millions to billions of rows of vectors with millisecond response times. And finally, the last one I want to focus in on is full text search. This is what allows you to filter on your text columns in order to retrieve the most relevant context for the user's question. Of course, we have a bunch of other search capabilities, and they've been on the screen for some time. You guys can go ahead and look up all of these different types of capabilities that SingleStore has. But now let's go ahead and see this in action in a RAG application. The architecture is very simple. You have your end user who's going to ask a question to your GenAI application. That question is going to be vectorized. And within a single query, you perform vector search. Perhaps you perform full text search. Perhaps you perform some sort of time series filtering to retrieve relevant information. But at the end of the day, because all of your enterprise data is living in one location, with a single query, you can retrieve all of the context for your LLM. You don't have to go to multiple disparate systems in order to retrieve that context. You can optimize SingleStore essentially to retrieve that information in millisecond response times. Once you have that, you can send it to the LLM as context and retrieve your natural language response. That's the power of having a singular system as at the base of your RAG application. That's the power of SingleStore. Now let's go in and take a look at a specific example of that type of query. Left-hand side, you can see your straight semantic search. This is just doing a dot product. Maybe you have some sort of vector indexing, and you essentially are doing a top 5 search. But with SingleStore on the right-hand side, you can see we are doing a hybrid search. And the most important thing I want you to notice here is not actually the fact that we are doing both a full text search and a vector search in one query, but I want you to notice 2 things here. One, we are using simple SQL syntax to query our database. You don't have to go and learn a whole nother language in order to query your vector database. But also, we are combining the full text score with the vector score to come up with a hybrid score. This is what allows you to re-rank your retrieved data based on context. So for example, if you want to hit some keywords very heavily, you would weight the full text score more. If you want to hit the vector score heavily, the semantic similarity, you would weight the vector score more. And of course, you can modify this, right? You don't have to do a simple weighted average here. You can, of course, implement other forms of re-ranking algorithms. It's entirely up to you, right? At the end of the day, SingleStore, given its capabilities, its multimodality, given its multi-model support, you can query basically any relevant data type and retrieve that information and re-rank it based on your application's requirements. So moving on, let's talk a little bit about the demo we're going to see today, right? So at the base layer, we have built a web scraper. What we've done is we've essentially gone to the SingleStore documentation pages. We've said, okay, I want to know everything. I want to build a RAG application that knows everything about SingleStore pipelines. So the web scraper went to the pages about SingleStore pipelines. It scraped the data, it chunked it, it vectorized it, it inserted it into the SingleStore database. Of course, you can imagine some sort of application architecture for your own enterprise's data, where essentially you have your scraper, which goes to the relevant documentation pages, scrapes all of the data, chunks it, vectorizes it, and given the scale, you dump it in an S3 bucket, for example. The advantage of SingleStore, like Mohan mentioned earlier, is you can just point a pipeline directly at that bucket. And in real time, as new chunks, as new CSV files, or as new Parquet files are uploaded to that S3 bucket, it's automatically brought into SingleStore. On the right-hand side of the screen, you see your end user. They're going to ask a question, right? So tell me about SingleStore pipelines, for example. That LLM application is going to perform a hybrid search. Again, it's going to perform that combination search that you saw on the previous slide between full text search and vector search in the SingleStore database. These query results, the relevant paragraphs, are going to be sent back to the LLM application layer, and there you are going to get a natural language response. So with that, I'm going to pass it back to Mohan to demo the application for you guys.
Awesome. Thanks, Rohit. As you guys can see, Rohit did a great job talking about the entire flow of the demo. So let's just get to it. What we did is we created a chat UI using Dash apps based on top of SingleStore database, right? So here you can essentially ask any questions that you want, and it'll only respond based on the knowledge base that we added to the SingleStore database, so that we know for sure that your answers are accurate, right? So let's just go and ask a question here. I'm going to ask about SingleStore pipelines. So I'm just going to ask about SingleStore pipelines and how I can get started. It should take just a couple of seconds to go look at its knowledge base and update with a detailed answer about SingleStore pipelines. And I'm pretty confident that this answer would be right because it is only looking at the documentation that we provided from the SingleStore point of view. On the flip side, let's try to ask a question and see if it'll make up an answer, or let's see if it shows what type of answer it would provide. So what is and it's kind of expected because we purposefully did not add database branching to the knowledge base to kind of show that it doesn't make up any answers, and this is the expected results that you want. Now, what we want to do is we want to go back to our database, update its knowledge base with all the articles about single store branching so that it can now come back and show us the right answers. But as we previously talked about, any big change that you want to do, you don't want to do it directly on your production database. This is where database branching comes as a huge value in improving your productivity, because you could instantaneously create a dev database, update the knowledge articles in there, and retry the search. Okay, great. I think I got logged out as I'm speaking, so give me a second. I'm going to quickly log back in.
We have a saying here, there's no great demo without being logged out.
Yes. Should just take a second. Okay. Let me do this. While this is loading, I'm going to show you my SingleStore portal overview screen. So as you can see, currently there's only one database. Let's just call it prod database. It's called RAG branching. And currently the chatbot UI is powered out of this database. What we're going to do is we created a Python, a notebook that has a simple SQL command that talks about how to create a branch, right? As you can see, it's literally a single line. I'm saying attach database. I'm pointing it to the parent database, and I'm saying as, and I'm naming it as RAG branching dev as the dev database that gets created, right? So I'm going to run this. While this is running, this should just take a couple of seconds, maybe a minute max. And what's happening over here is that we are cloning the data, right? We are not duplicating, we're just cloning the data so that as of this point in time, the new database that we create will have all the data that the RAG branching database will have. And as you can see, it just took about 20 seconds to create, so it's not too much time. And because we are not duplicating, the best part of this is that if you have multiple developers or even testers, you can create a branch for each of them, and they can have their own playground that they can go and prototype and test their applications without incurring too many storage costs. So just to validate if the branch has been created, I went back to my overview screen to see what is the new database that gets created. So in this case, you can clearly see that there's a dev database that got created, which we just did as part of the branch. And this will have all the data that the RAG branching has. So what we'll do is now we will add the new documents that are based on database branching in here and enhance or augment the knowledge base for the dev database so that we can rerun the chatbot and see if we're getting the answers as expected. So let me just run some of these scripts and then I'll talk through them as they are loading. I need to put my API OpenAI API key over here. So just give me a second. Before I forget, I'm going to switch to the dev database because that's where we want to add the new knowledge articles. Okay, I'm going to run the Python script. So here, as Rohit previously explained in the pipeline, what we're doing over here is we are scraping all the data that is based on this database branching SingleStore documentation page, and then chunking it and embedding it into the dev database. As you can see that ran. Let's just test it. Let's see if I can see all the chunks and vectors. As you can see, this is the beauty of SingleStore is that your vectors are just another column next to your primary database. It's not a separate vector database sitting at a different location, and this drastically improves the performance. Okay, so all of the data is in the dev branch. I'm going to go back to my dash app. I'm going to switch the database. Remember, the new knowledge articles that we added are in the RAG branching dev database. So I just switched the database over here and reran the query. And as you can see, we have the answer that we're looking for. So just to quickly summarize, what we did is we showed the value of database branching and how you can instantaneously create a staging environment prototype. This is where you can drastically improve your productivity and then test to make sure it works exactly the way you want. And at this point, you could replicate this on a production database or just make this branching this database your new prod database to support your critical applications. I'm going to hand it over to Rohit to just talk a little bit more about his chunking strategy in writing this Python script, and then we can open it up for Q&A.
Awesome. Thank you, Mohan. That was a great demo. So essentially, just talking a little bit more on the RAG side of things. What we've done in this script is we've gone to the documentation page for SingleStore's database branching, right? And of course, we created a branch ourselves just to make sure that we're going to get good answers from our chatbot. You know, maybe the documentation page itself is not great, and we need to do some A/B testing beforehand. But the way that the scraper has worked is essentially it's gone to the documentation page. And as you can see in this function text embedding df, it has retrieved the text from the documentation page, and it has created an embedding for each chunk using the get embedding function. Now, the way that I have decided to chunk this, just because we wanted a demo that could give you the idea of what database branching is we have chunked based on paragraphs, as you can see in the creation of the pandas data frame. So we've gone to the documentation page, we've gotten the text, we've chunked it based on paragraph, we've got a vector for each chunk, and then we are inserting that into the SingleStore database into a single table. So that's kind of the flow of the scraper over here. And then on the other side, of course, we are performing a hybrid search in order to be able to retrieve relevant information.
Awesome. All right, I think we can now open it up for Q&A. So feel free to ask any questions. I know we covered a lot today, but we're happy to answer any questions that we have, or also follow up if needed.
That was so cool, Mohan and Rohit. Thank you so much. And for everyone, just an FYI, we will be sharing the link to the code very soon. So I saw some people raising their hands. Just please use the Q&A button and we will be able to answer your questions live. So we actually have a few questions. We have one very nice question from Kanan. He says, high data branching is possible in multiple containers with a question. What do you think?
So what was the question again?
Is database branching possible in multiple containers?
So container is more of a compute concept, right? So right now, database branching is more at the storage layer, right? So SingleStore has a concept called workspace groups. Within a single workspace group, you can create as many workspaces or nodes that you need to run your to support your databases. So within that workspace group, you can create as many databases that as you want, because that workspace group shares a single storage bucket. So because containers are more of a compute concept, I don't think how it will be relevant in this. But the short answer is you can create as many databases or branches as you want within a single workspace group.
Right, that makes sense. So question from Robert, can you please share the notebook that you showed us? Yes, we will be sending a follow-up emails and that will have the code to the demo. So stay tuned for that one. We will be sharing the follow-up emails, I think, in about 10 hours because the team is across all over the world. So they are in different time zones. So yeah. So we have one question from uh, Jenny. I'm very sorry if I'm not able to pronounce the name correctly. So she says that does this platform have a prod environment at UAT environment? Like, does it make sense or does it a typo?
So it has a prod environment and a UAT environment. Is that the
I think
question?
so. Yeah. Yeah. Yeah.
Okay. So prod and UAT environments are something that you can create. And when you're creating, as I said, I was talking about the concept of workspaces that SingleStore supports. When you're creating a workspace, you can tag saying that, hey, this is my prod workspace, or this is my UAT or testing non-prod workspace. Now, databases are just databases, just a database with a bunch of data in it, right? So you can create any database as a branch within that workspace group and then tag it as a prod or non-prod based on your business process. But from single source point of view, all of these are just databases, and the durability for it is 4 nines. Oh, sorry,
All right.
availability is 4 nines. Durability is much
All
higher
right.
than that.
Okay. Rohit, is there any question that you want to take up?
I think I answered a couple already through
Yeah.
text. So
Is there anything you want to take up live?
Yeah, maybe you
uh,
can answer some of those questions live. Yeah, that's a
Yeah,
good
we
idea.
actually have more questions coming
yeah.
in as well. So uh, let's take up any one question that Rohit
Yeah.
has not answered.
Yeah.
So
So
we have a question from Bill Reynolds. He says, can you clarify the SS doc statement? Branching is currently supported only via SQL, for example, versus Sky and notion of multi-model database.
so that's a
Okay.
great question. Oh, do you want to answer that, Mohan? Go for it.
No, go ahead. No worries. Go ahead.
Yeah, so SingleStore has a couple of has a couple of different features around integrations and around migrations from other databases. So SingleStore Kai, for example, exposes SingleStore as a MongoDB API endpoint. So essentially, you can query your SingleStore database with essentially the same commands that you would query a MongoDB database. This is kind of more geared towards those applications which are built off of MongoDB, but are struggling with, for example, analytical style queries. So essentially, database branching as a feature is only accessible through the SQL interface, right? So you can't run a MongoDB style query in order to create a branch of a database. That will have to be done through SQL, like you saw today in the demo.
Right.
On the flip
So
side, the positive thing about this is that if you want to create a branch completely from the single store portal, we will support a new cool UI in the near future. So it'll be just a click of a button where you can go and create a branch right off that. So you're getting multiple ways to do it. One via UI if you want using single store portal, or obviously SQL, which is something that everyone knows how to use.
hey, that's super helpful. So we have one more question from Elias. They say so database branching is read only on the current database and writes on a different layer. Is that statement correct?
It's not. So think of it to go a little bit under the hood. What we are doing is that we store everything in our object storage as blobs, right? So think of it that when you create a branch, 1, 2, 10, whatever number of branches, these are just reference points pointing to the blob. So what that means is that once you create a database, once you create a branch, that branch, as I showed you, will show up as its own independent database. So that is just just like any other database, it's an independent database. So you can now treat it as a read and write database or read only database. And so you can update, do delete, or do any changes to the data in here, and it does not impact your primary database. Right. And the reason we are doing that is because we're just counting the references. And as long as a reference or a branch is pointing to that blob, we will never delete a blob. And so it's always going to stay there till all your databases are dropped. So in short, yes, it can be a read only, but it can also be a read write branch.
Makes sense. Okay, so we have one more question from Akhil. They say, can this DB structure be used to integrate with Kubernetes deployments?
Rohit, I think the answer is yes, but you want to take that?
Yeah, I believe the answer is yes. So SingleStore can be deployed in a Kubernetes environment. So database branching as a feature should be available through that.
Yeah.
So we have one question from Ravi S. They say, what is the pricing model for each DB instance? Is can SingleStore support Oracle-based OLTP database to bring as OLAP along with the vector DB? So I think this question can be better taken offline because I think it differs according to your use case. So I will give you an email that I think it's team@singlestore.com if that's correct. And you can mention this webinar title in the subject and I think our team will get back to you. I think Rohit, but we do have a pricing page if that's correct. If you can point us out to that in the
Yeah.
chat,
Yeah,
that would
yeah,
be
we do
nice.
have a pricing page.
Awesome. Okay. So Ravi,
Yeah.
in the meantime, you can go through that and feel free to email our team and we'll reach out to you. And I think they'll be able to better assist you with that. So, okay. Um, we have one question from Veda. He says, does it support data masking for test environments?
Unfortunately, today at this point, it doesn't, but data masking for especially PI information is in our roadmap. So right now we are just branching the database, which is we just cloning the data, but we're not masking anything. But that's in our roadmap. So stay tuned.
Right. They are always developing some interesting features that we are always
Yes.
tuned with that. So that's good. So we have one question from Jerry. They say, does database branching work in an on-prem implementation or only in your cloud-hosted environment?
Yeah. So unfortunately, today it only is supported on our managed cloud hosted environment. And again, the whole reason is because of the storage layer. We build our own unique storage layer for this to work, along with a control store on top of it to make sure that we count the references of the blobs that I was explaining. So today it is only supported on a cloud managed platform, which we call Helios Cloud. But depending on the demand, we will explore supporting it as a self-managed feature as well.
All right. So do we have more questions? Because we do have some time. So
Yep,
all right.
keep them
So I
coming.
think yeah, you can keep them coming. If no, then we can also go ahead with like the raffle winner and other announcements. So there's a question from Parth. He says, "What is the data? What happens if the database size is too large?"
In terms of branching or in terms, so I'll assume I'll take that as the question is in terms of branching, and the answer is nothing. Your performance doesn't change, right? Because again, the performance changes based on the size of the database if you're duplicating it, right? But here we are not, we're essentially cloning it. So because these are just references that you're keeping a count on, even though you have hundreds of terabytes, taking a branch of it will still take a couple of minutes. So we have a concept in SingleStore called attaching a database to a workspace and detaching a database to a workspace. So you can visualize it in this way that the time it takes to branch will be about the same time it takes to attach a new database to your workspace. And workspace here is compute. So no matter how big your database is, you should not see any performance degradation when you create a branch.
All right. So if we don't have any more questions, we can wrap this up. And we have just a small reminder for anyone that joined late. We have amazing webinars that are coming up and they are present on your screen. If you can please go back to the previous slide. Thank you. And just quick notes before I announce today's raffle winner. On 14th, we are presenting Getting Started on SingleStore. August 16th, we have How to Make Full Stack MongoDB and JSON Apps Faster. And on August 19th, we have LLMs in Financial Services, Personalized Portfolio Recommendation Engines. If any of these topics are interesting to you, feel free to RSVP, and I hope to see you all there. So, and the announcement that everyone's been waiting for, today's raffle winner, it goes to Sohail Rahman. He's a director of software engineering at Paraxel. Congratulations and thank you for joining, sir. And if that is not you, do not give up. As I said earlier during the session, we are going to announce one more AirPods winner by the end of the day for anyone who has tried out today's demo. Sign up at the link that's present on your screen and just be entered to win. Thank you so much to Mohan and Rohit for coming up with this amazing demo and whatever new innovative features that they keep on rolling out. Really appreciate it. And thanks everyone for attending. Have a good day, good evening, wherever you are. And if you like this webinar, feel free to give a shout out to us on LinkedIn. And I hope to see you all again during our next webinars. Take care, everyone. Bye-bye.
Thank you everyone for joining.
Thank you.
Bye.